ensconced in an area that some of you might not be entirely familiar with, and that is the world of machine learning competitions. No, I didn't just take 3 English words and randomly put them in an order. That's an actual thing, machine learning competitions. And I actually think that what I've learnt from those 3 years in this world is something that's going to affect all of us. And so I want to share it with you today. So let me start with an understanding of what this thing is before we understand how I think it's actually going to impact us in the future. So machine learning competitions, let's break it apart. What is machine learning? Well, it's a word we've probably all heard, but maybe some of us don't fully understand. And the simplest way to understand it is to go back to the very first person who did machine learning. Think back, it's 1954. One of the earliest programmers is trying to write a program to play checkers. There's 2 problems. The programmer is not very good at checkers. The second problem is, even if he was, he wouldn't know how to turn that into a sequence of rules for a program. So at this point he's stuck because he wants a program that he can actually play at checkers and get better himself. So he did something genius. He did not tell the program how to play checkers. He told the program the broad parameters which would define all of the possible checkers playing approaches. It's basically as a sequence of numbers. He then had the computer play itself thousands of times. And the times where that randomly chosen sequence of numbers was better, it would kind of keep more of that approach to playing checkers. And over thousands of games, actually, the checkers program taught itself to play checkers. And it actually got to the point where it could easily beat the original programmer. Now that's what machine learning is. Machine learning is giving a computer a broad approach or a broad set of parameters within which it can create a solution to a problem better than your own solution to that problem. And today, it's really taking over the world. So when you go to Google, let's think back to the example from one of the earlier speakers. What happened when Google took over Yahoo? How was it that that single search box could do better than hundreds of human editors, experts at finding and ranking the world's best websites? Well, it actually used a machine learning algorithm called PageRank, which was very good at turning your search query into a prediction of which websites you might be most interested in going to. And that really took over. It's even taken over in places like retail. When you go to Amazon now, most of that screen space is taken up with a list of books and other products that you might enjoy. Again, using a machine learning algorithm. It's not a sequence of rules that someone's programmed in, but the computer has figured out for itself what you might like. When you go and try and buy an airfare, the price that it comes up with on most sites is developed by a machine learning algorithm which figures out what's the highest price they think they can get away with and still fill the plane. So today, machine learning is everywhere. But there's something else interesting, and that's the second piece, which is competitions. The really interesting thing about this is that if you compare my algorithm to your algorithm, we can actually come up with a number about how good it is. For example, think about Nate Silver, who used a statistical approach to predicting the election. We can clearly say he got every state correct, whereas this pundit got significantly less than every state correct. And now think about doing that for 1 million insurance policies. So my algorithm says that these 1 million insurance policies will have exactly these level of claims for each one, and yours says it'll be these. And we can compare, we can score them. And this is actually the only place I'm aware of outside the world of professional sports where you can actually come up with a number about how good somebody is. So think about the world of sports, right? In the world of sports, this ability to compete against each other actually lifts the bar for everybody. And this has now been happening. There's been hundreds of competitions where data scientists compete against each other to come up with the best predictions. And they get scored, and there are winners and there are losers. And there are literally now world rankings of data scientists. The extraordinary thing about this is every time there's been a competition, the result of that competition has been an algorithm better than any one that has ever been created before in that area. And so being part of this world for 3 years, I now know what the world's best algorithms in nearly every area look like. And it's extraordinary. The first really extraordinary thing happened in mid-2011. Up until that point, there had been a group of things which people had always done better than machines. And broadly speaking, they were looking at things and understanding what was being seen, reading text, writing text, and combining a knowledge of the world together in a kind of a flexible way. In mid-2011, for the first time, the winner of a machine learning competition came up with an algorithm that could understand images better than humans. Specifically, they were traffic signs. It was a quirky, niche little competition. Could you come up with an algorithm that could recognize a traffic sign amongst hundreds of traffic signs, different weather conditions, different lighting conditions? And the best human who had been tested had a 1.5% error rate. And the winner of this competition had a 0.7% error rate. Now, this was a big deal. It wasn't something that got any publicity. It was very niche, but it signaled a turning point. And the interesting thing about this turning point is machine learning is a fundamentally leverageable technology. What do I mean by leverageable? What I mean is that by definition, it's an exponential technology. As people get better at it, at defining the broad scope for the computers to then solve the problems, the computers then get exponentially better at solving them, because the computers get exponentially more powerful, and they get to use the previous machine learning answers, and they get to use more and more data. So since 2011, suddenly it's all been toppling. So understanding language, there was recently a machine learning competition where a computer actually graded handwritten student essays, 30,000 of them, more consistently with two teachers than the two teachers did with each other. So we're now at a point where computers read better than teachers. There are now algorithms that write prose of a quality that is regularly published in Forbes magazine. About a month ago, a Stanford research group came up with an algorithm that can read tweets and decide whether they seem to be of a positive or a negative sentiment. That's something where humans generally agree with each other about 85% of the time. This algorithm also agrees with humans about 85% of the time. It's got to a point, this exponential growth now, it's surprising everybody. You can see it with something like the Google self-driving car that can drive around. It's driven 1 million miles with a LiDAR sensor on its roof, using machine learning to try and figure out what are people, what are trees, what are cars, what are they going to do, how should I react? Out of those 1 million miles the self-driving car has driven, it's had one accident, and that was when they turned off the autopilot. So we're really at a point now where computers seem to be able to do nearly everything better than people can. Now, we've seen something like this before. It was the Industrial Revolution. Now, in the Industrial Revolution, humans have been doing agriculture and manufacturing, and we were very resource constrained. And the result of the Industrial Revolution was a massive increase in productivity. But actually, did you know for the next 100 years, at least in Britain, most people had a lower quality of life than they did before the Industrial Revolution. Quite extraordinarily amount lower. In fact, children as young as 4 were working. I believe the statistic was 80% of people in Britain had at least 20% or more. That's how far they were below the poverty line, which is a decent level of life. So like, literally most of the country was not getting by. Now we know it turned out okay, eventually. And it turned out okay because of services. 4 out of 5 Americans today are employed in services. Services involve things like looking at pictures, reading text, writing text, and bringing knowledge together. All things which, about as of now, computers are better at or about to be better at. So what happens next? Will there be a 100-year disequilibrium where there's a massive income equality gap? The data says perhaps. In fact, already, Sloan MIT has done analysis that strongly suggests that there's already a fundamental employment gap worldwide caused by there just being not enough work for humans to do that's of any value. That's only going to grow. And this time, will there be something to save us? In the Industrial Revolution, eventually we found services. But when computers can do those too, what's next? I think this is something we need to be thinking about. What are the social policies that we're going to be putting in place to ensure that as we get to a point where scarcity is reduced and the world should be better for all of us, the actual distribution of income is such that we can all enjoy it? Thank you.